The largest NASA Hubble Space Telescope image ever assembled, this sweeping bird's-eye view of a portion of the Andromeda Galaxy, M31, is the sharpest large composite image ever taken of our galactic next-door neighbor. Though the galaxy is over 2 million light-years away, the Hubble Space Telescope is powerful enough to resolve individual stars in a 61,000 light-year long stretch of the galaxy's pancake-shaped disk. It's like photographing a beach and resolving individual grains of sand. And there are lots of stars in this sweeping view, over 100 million, with some of them in thousands of star clusters seen embedded in the disk. Hello and welcome to KYC News. Please don't forget to subscribe and hit the bell icon. This ambitious photographic cartography of the Andromeda Galaxy represents a new benchmark for precision studies of large spiral galaxies that dominate the universe's population of over 100 billion galaxies. Never before have astronomers been able to see individual stars inside an external spiral galaxy over such a large contiguous area. Most of the stars in the universe live inside such majestic star cities, and this is the first data that reveal populations of stars in context to their home galaxy. Hubble traces densely packed stars extending from the innermost hub of the galaxy seen at the left. Moving out from this central galactic bulge, the panorama sweeps from the galaxy's central bulge across lanes of stars and dust to the sparser outer disk. Large groups of young blue stars indicate the locations of star clusters and star-forming regions. The stars bunch up in the blue ring-like feature toward the right side of the image. The dark silhouettes trace out complex dust structures. Underlying the entire galaxy is a smooth distribution of cooler red stars that trace Andromeda's evolution over billions of years. Because the galaxy is only 2.5 million light-years from Earth, it is a much bigger target in the sky than the myriad galaxies Hubble routinely photographs that are billions of light-years away. This means that the Hubble survey is assembled together into a mosaic image using 7,398 exposures taken over 411 individual pointings. Over 30 additional galaxies that are thought to be a part of the local group are thought to surround the Milky Way galaxy. However, the Andromeda Galaxy, our big sister, is larger than our own galaxy. Despite being among the closest to our own, 2.5 million light-years separate it from us. Unfathomable distance. Andromeda, like the Milky Way, is a spiral galaxy. We can consider it to be a big sister because despite the fact that the two have a lot in common, Andromeda is significantly bigger. Indeed, it is so. It is the farthest object that can be seen with the unaided eye since it is so big and bright. Compared to the Milky Way's 200 to 400 billion stars, this enormous galaxy has nearly 1 trillion stars. Andromeda has a diameter of more than 200,000 light-years, making it roughly twice as big as our galaxy. How did our massive neighbor become so large, and what is hidden within its dazzling galactic center? Near the same time, the Milky Way and Andromeda most likely originated. 13.5 billion years ago, the universe first appeared. Both of these galaxies have expanded by eating other galaxies they have crashed with throughout their lives. And one day, even we and Andromeda will clash. While it is expected that the initial collision will occur in about 4 billion years, computer simulations show that the galaxies won't entirely combine for another 2 billion years. We will no longer be a spiral galaxy once we combine. Instead, with magnificently outstretched arms of dazzling stars by that time, we will have transformed into an immense cluster of stars known as an elliptical galaxy. Here is a rendering of what our sky would have looked like soon before this momentous fusion by an artist. The Milky Way and the Sun also share a likeness, and the similarity between Andromeda and other galaxies is that both feature a brilliant star-filled center bulge. Both of them are concealing a gravitational monster in the center of all these stars. An extremely large black hole. Supermassive black holes are simply that, extremely large black holes. weighing millions to billions of times as much as our sun. Astronomers do not fully understand why these enigmatic dark objects become so enormous, but they think it might be related to the fact that they are at the galactic center of their host galaxy. The Milky Way's supermassive black hole, which was discovered not too long ago, this magnificent image, which was the first to be taken of the object designated Sagittarius A*, reveals nearly every big galaxy in the universe is thought to contain. There may be a second supermassive black hole. While magnificent pictures like this one display Andromeda's dazzling center bulge in 1993, astronomers were shocked to see a ring of brilliant stars encircling the mysterious black hole. Find two light-filled blobs surrounding the center. One appears blue, whereas the other does so in red. Astronomers realized in 2012 that the blue blob is a collection of young, the supermassive black hole in Andromeda, which is also present at the center of this, suggests that it might be a characteristic of many galaxies, including the Milky Way. However, the central red blob of Andromeda is actually a lopsided elliptical disk of the supermassive black hole, and the blue cluster are surrounded by older stars. Not to our eyes, this red star disk in the Milky Way, prompting scientists to inquire about the history of Andromeda. That may have produced this enigmatic disk, and what caused it to be uneven. Astronomers may have recently discovered the solution to this question. Additionally, a massive cosmic collision is involved. About 100 million times the mass is contained in the Andromeda supermassive black hole, and it is almost 25 times as large as Sagittarius A star of our sun. However, it seems unlikely that Andromeda's black hole was always as big. Rather, it developed over time. By consuming everything it came into contact with, even other black holes, it extended its lifespan. The enigmatic lopsided disk may have been generated by this cosmic-sized appetite of old stars found at the center of Andromeda. What precisely may have happened, then? Well, the following is suggested as the assumed timeline of the events. A galaxy collides with Andromeda more than 1 billion years ago, and they start to converge. As the galaxies collide, Andromeda's black hole approaches it. They start to orbit each other in a frenzied dance around the smaller black hole. As a result, matter from the galaxies falls in the direction of the black holes and starts to orbit some distance from the sun. Eventually, this material condenses to create new stars, encircling the dark holes with a ring. In a dramatic occurrence, the black holes eventually combine, creating a surge of gravitational waves. This burst may occur if one of these merging black holes is significantly smaller than the other. Not evenly in all directions, but they can be more concentrated in one. This unbalance, the freshly created black hole may kick in one direction as a result of the explosion, sending it shooting accelerated to high speeds, possibly 200 kilometers per second, 125 miles per second, roughly. The orbiting stars also receive a kick as a result, and their circular new elliptical orbits are created when orbits are perturbed. This new orbit, however, they accelerate as they move nearer to the black hole and decelerate as they travel farther away. This could be the reason why the disk in the center of Andromeda appears to be asymmetrical, with one very positive aspect is that when stars go further, they accumulate in a pile as they slow down. Black hole, from there. Since the blue star clusters we observe are younger, they would have developed much later through a variety of potential outcomes. However, this is simply one conceivable set of circumstances that could have led to what we see in the Andromeda center right now, and while this new piece of art is just the beginning, but it is a terrific first step towards comprehending what is happening. We will be able to peer further and deeper into the centers of nearby galaxies as technology advances, giving us additional knowledge about the evolution of galaxies throughout their billions of years of existence, including our own and Andromeda. I hope you enjoyed this trip to the center of Andromeda. If you did, please click the like button. subscribe to my channel. It helps to support me. I appreciate you watching, and I'll see you again soon.